Hello everyone and welcome back to Code Compass. Today we are going to solve Jump Game 2 from Leetcode Top Interview 150 list. So this is actually an extension of the previous Jump Game problem that we have done. So just go back a few videos, watch that one first so that you properly understand how exactly is this one an extension of that particular problem. So over here, if you remember in Jump Game, the idea was to basically find out if we will be able to reach the last index in a given array if we are positioned at the very first position, and each value represents the total number of jumps or steps that you are allowed to take from that particular position. But over here they have slightly extended the problem, and now they are asking return the minimum number of jumps to reach index n-1. So now overall problem is still same, you have to reach the last index, but they want to know what is the minimum number of steps that you can take to reach the last position. So let's see this particular example over here. So 2, 3, 1, 1 and 4. At the starting position 2, you have two options. You can either reach position number 3, the value 3, or the value number 1. But if you decide to take just one step from 2 and reach 3, then from 3 you can directly take 3 jumps and reach the end of the array. So within 2 jumps, which is also the output of this particular example, you can reach the last position. Whereas let's say you decided to jump 2 steps from the starting position, then you will end up over here 1. From 1 you will have to jump to the next one. So now you have already taken 2 jumps, and then from over here you will have to jump to 4. So in total you will take 3 jumps to reach the last position. But they are asking us to figure out like what is the minimum number of jumps in which you can reach the last index. So this problem actually has multiple solutions. It has a DP solution as well, but the solution that we are going to discuss will be a linear time solution which does not require any extra space and only requires one traversal of the array. So just take a pause, try to think of this solution yourself, and once the intuition becomes clear to you, the code is very simple for this particular problem. So let's go to the intuition for this problem. Okay, so now let's try to understand the intuition behind this problem. Okay, so what does our problem say? That we have this array 2, 3, 1, 1 and 4. We are standing at the 0th index, which is the very first position. These are the index numbers I have just written. So we are standing over here, and what are the options of jumps that we have? So we can either jump 1 position, which will land us over here, or we can jump 2 positions, which will land us over here. So this basically, this particular range, I'm calling this as a range, which is a subset of the array. This range is the basically next possible steps that can be reached from my starting point, which is position number 0 containing the value 2. And by this time, if I doesn't matter wherever I go, either I go to 3 or to 1, I have taken 1 jump. So let's keep a track of jumps as well. So now so far I have taken 1 jump. Okay, now things become interesting. So for the next basically jump, now I have to decide which is the farthest position I can reach. So but now I have 2 possible options. So just considering the jumps from 1 position is not going to be enough. I need to understand which are the possible ranges that can be reachable from this particular range. So what I'm trying to do, I'm trying to break down my array as we are traversing into basically intermediary ranges. So a range is basically a section of the array which is reachable by the previous range. So for the starting, we will always be at the 0th index. So I will consider that initially I just have one element in my range, okay, which is initially 2. So let me write this again, then things will become more clear. So this is my initial range basically. From here, now my target is to identify what is the last element that is reachable from this particular range. So since it has only one element, the last element reachable will be 1. So next range will become this. Now let me call them as range number 1, range number 2, and now I need to decide what is the farthest reachable position from any element of this particular range number 2, because every element of range 2 is reachable from any element of range number 1, but number 1 has only one element, so things are pretty simple. So now let's say you take one step and reach 3, or you will take 2 steps and you will reach 1. Now you have entered range 2. So any jump from range 1 to range 2 is going to cost us 1 jump. Now I need to see what is the farthest position that I can reach from range number 2. So let's say I start from this particular element which has value 3. So what are the possible jumps that can be taken from this particular position? It can either be a single jump. So if we take single jump from 3, we end up over here, which is 1. Or we could take 2 steps, then we will land over here. Or we could take 3 steps, then we will land over here, which is 4. Now let's forget about 3. Let's say we start from this position. So the only option that we have will be taking a jump of a size 1. So we will land over here. So now if you see your next range, basically range is the last position which is reachable from the previous range. So what is the last position which is reachable from range 2? That is 4. So this becomes our next range. And the starting point so farthest point is clear, like where the ending position of my range will lie, that is clear. Where will the starting position of the range lie? That will always be the next element from the last element of previous range, because we are safe to assume this because the question has mentioned that it is like at least one solution exists. So obviously we will always be able to reach the next range from a previous range. What we are going to do is we are going to maintain a couple of variables which will help us define the boundary of the range that we are currently operating on. So just in short, I will be defining 2 variables. Let's call them as left bound and right bound. So in the initial, when we are just beginning the traversal, we will be located at very first element of the array. So left bound will be 0, right bound will also be 0. So we have a range whose size is just 1, which is this one. And at each step, we will try to find out whichever is the farthest position reachable from this range. We will update the right bound, we will update the left bound, and then we will see at each step we will keep incrementing how many jumps we have taken, and in the end we will have basically the total number of jumps that we have taken. So, and by the way, when do we stop? We will stop whenever the right bound, which is the last position of my current range, whichever range we are working on, ends up coinciding with the last element of the array. So basically we will keep continuing till right bound reaches the last element. As soon as that happens, I don't need to take any further jumps basically. So because as soon as you reach a range which contains the last element also, then it means that no further jumps are required. So you are safe to conclude the iterations and basically return whatever jumps you have calculated so far. So let's see the dry run for this problem, and then things will become much more clear, like how these left bound and right bound are getting calculated, and how exactly we figure out like where to locate the right bound. So right bound will basically needs to be updated to the point which is the last reachable point from any particular range. And for that, what do? We will basically just we will iterate for I in range. I'm just writing the pseudocode in range left bound to the right bound, whichever is the farthest reachable position, and we will have like a temporary variable which will tell you which is the last reachable position from the current range, and let's call it as farthest. We will basically find out in this particular range which is the farthest reachable position, and whatever that is, that will basically be from index I. This will be the farthest reachable position from each particular index, and for all the indices lying between this range, we will calculate farthest and set it to right bound. So let's try to see a dry run of how these variables are getting updated, and then things will become much more clear. Okay, so let's see the dry run. So now here on left hand on the very first column, I have written the range, which is telling us what are the left bound and the right bound of the current range that we are operating upon. Farthest will be the last reachable position from any point within this range. Okay, and jumps will be how many jumps we have taken so far. So from the starting, when we are just beginning, we will be placed at position this value, the very first index of the array. So left will be 0, right will also be 0. So we have a range with only one element inside it. Okay, now farthest is basically calculated as we can call it as last reachable point in current range. So from the current range, which is 0, 0, which is the position number 2, what is the last reachable position? That will obviously be I plus numbers of I. So I is 0, 0 plus value of I is 2. So farthest becomes 2. And I have obviously now taken one jump up until this point to reach the next range. And now the next range becomes, the starting point will be the ending point of previous range plus 1. So the starting point becomes 1, and the last the right bound becomes the farthest reachable point, which is 2. So now we are operating upon this particular range. Okay, now again let's try to update farthest. Let's try to calculate the farthest position. So farthest position now will be maximum of either from 3 I can reach, the index of 3 is 1, the value of 3 is 3, or I can start from this particular position. So the index over here is 2 plus its value. Its value is what? 1. So it will now become maximum of 4, 3. So now the farthest position reachable from this particular range becomes 4, and I have taken another jump. So jumps will become 2. Now for the next range, again let's repeat the logic. The starting position will become the ending position of previous range plus 1, which will be 2 plus 1, 3. And the ending position will be the farthest reachable position from the previous range, which is 4. So over here, as soon as we see that, okay, I have reached in this particular iteration, my farthest reachable position, which is 4, is equal to the last position which we were intended to reach. So it means that I no longer need to perform any more jumps, because we have reached the last position, which is the 4th element, in just 2 jumps. So our entire processing will stop over here and we will just simply return true. So just try to see the dry run for this once again, and once we write the code for this, things will become much more simpler, because the code is really straightforward for this particular problem. So let's go to the code and try to see how simple things actually are. Okay, so now that you understand the intuition behind this problem, let's try to write down the code for it. So I will start by defining the few variables that we had discussed. I will be calling them as left bound, which will be 0, and a right bound, which will also be 0, which will basically be the bounds for the starting range basically. And this left bound and right bound will always ensure that you always are keeping a track of the current range that you are working on. And I will keep a counter for jumps, which will be initialized with 0, and in the end I am going to return this one. Now let's start the actual logic. So what I will do, I will keep iterating until my right bound is less than numbers.length minus 1. So why minus 1? Because I am not supposed to, they are not asking us to go beyond the array. They only want us to reach the last element itself. So that element will be basically placed at numbers.length minus 1. But as soon as my right bound becomes equal to or greater than the last index, it means that I have reached the last element. So I will stop my iteration as soon as right bound goes beyond the last index in the array. So this will keep happening, and inside it, what I am going to do, I have two things which I need to do. I basically need to find out the farthest reachable position from this particular range and accordingly update my left bound and right bound. So let's see, let's traverse from left bound till the last index in the current range, which is right bound, and I will have to find out the which is the largest reachable farthest reachable position within this particular range. So let me define a local variable farthest. I will initialize it with right bound. And why I have done that? Because so let's say you are not able to take any jump in the given range, then anyway the ending position of this particular range will obviously be reachable. So I have just initialized with that, and after that inside the loop I am going to update this to maximum of farthest comma my current index plus wherever I can reach from this index. Simple as that. And after now I know which is the largest reachable position from the current range. I will update my left bound and right bound for the next iteration. So left bound becomes whichever was the ending position of my current range plus 1, and right bound will become the largest reachable position, farthest reachable position from the current range, and I have taken 1 jump. Cool, as simple as that. Very simple code. Let's see if this one works or not. Great. So the base test cases are passing. Now we will see if all the test cases pass or not. Great. So all our test cases are passing. So I hope the explanation and code are both clear to you for this particular problem. This problem has a lot of variations in terms of its solution, but this is the most optimized and linear time solution possible. So I hope you enjoyed the video, and if you liked our content, please subscribe to our channel. I'll see you in the next one.